So I'm doing a talk on Git. I mentioned Midjourney before, and this was actually also generated with Midjourney. I literally just said a developer under the covers, and it came up with this, so it kind of worked quite well.
Looks a bit like you.
That's coincidental, but weirdly, on the walk here, we walked past a bloke, and he looked literally exactly like him, and it was like, whoa, that's kind of weird. Cool, so I'm going to talk about Git. Now, I'm going to assume that everyone here kind of like knows Git and uses Git. I'm not talking about what Git is, why you should use it. I'm not talking about rebasing or merging or any of that stuff. We're going to go a bit more under the covers. But first, a quick introduction to myself. We've seen this slide in the intro talk, so I'm going to skip this. It's just my company. You've seen this slide, so I'm going to skip this as well. But if you want to go and check out the podcast on the YouTube channel, then you've not seen this actually. So I've recently just started a newsletter. And this is just like a monthly news items once a month, and also bits and bobs of what I'm up to with the podcast, this, .NET Oxford, the YouTube channel and stuff. So it's like just once a month, like lots of .NET news, so software development kind of stuff. So if you're interested, sign up there. I can pop that on the Discord as well if anyone's interested. Outside of work, I'm married to the lovely Anna, and I've got two amazing boys, Jack and Mason, which are far too energetic, but they're worth it. But looking at this picture, I can actually understand now why I have a very bad back. And then can't forget our other family member, which we last year we got him. He's now nearly a year old. He's quite a bit bigger than that, and because I'm a complete nerd, we called him Scratch. So Git. So I'm assuming everyone knows Git and everything, so we're going to go a bit under the hood. Git has got sort of Git objects, and this is kind of how things are stored under the hood. So we've got the commit, the tree, the blob. Annotated tag I'm not going to talk about because it's a lightning talk. We don't really need that one to understand how things fit together. And I'm sure everyone knows like this kind of char kind of hash kind of thing at the bottom. You probably associate that with a commit, but all of the different object types have like a char, so it's SHA1, a hash of what the object is. If you look in if you've got a Git repository and you look in the objects folder, so there's a .git folder, we've probably all seen it. There's an objects folder, and you've got like this kind of folder structure. Now you might have a pack file that's like a compressed version of this, or it might be like individual files like this. But these are basically representing each of the Git objects. So the first two characters of the directory is the first two characters of the char, and the file name is the rest of the char, but it's the char we're interested in. That's just how it's stored. So looking at the commit object, this is probably less than you actually think it is. There's a command we're going to be looking at called git cat file, and it outputs this kind of format, and we'll see it in a bit. But this is kind of what's stored in a commit. You've got like the commit message. You've got a pointer to the tree. You saw the tree object before, which we'll talk about, which is just, say pointer, it's the char of that other object. You've got a parent, which is the char to the previous commit. Now imagine it's a merge commit, so you might have multiple parents. So there might be multiple parents listed there. You've got the author, the committer, and the timestamp. So that's pretty much it for a commit object. And then the char you saw is kind of like the hash of just this information. So going back, you saw there's a tree, a pointer to the tree object. If you do that same cat file command, which we'll see in a bit, on the tree, it looks more like this. So this is basically like doing an ls in a directory. So the tree that's pointed to by the commit object is the root directory. Now it's worth pointing out that this is a commit in Git isn't just what you committed that time. So that this listing isn't just related to what you committed. It's like, you might hear people say that a commit is like a snapshot of the entire repository. It's a very heavily cached snapshot, as you'll see, but it is kind of. But that tree is at that point in time of the commit. It's the entire work, like the entire first directory, like doing an ls in that directory. And we can see it on the left hand side. We've got blob and tree, so we've got types. We've got pointer to the next object, and for the blob object, a blob's a file effectively. You've got the file name. For the tree object, I've called it subdirectory. This is just the name of the directory, so it's a pointer to another tree object. So if we look at a blob is just the file content, nothing else. It's nothing to do with the file name. The file name is in the tree here. The path is inferred from the hierarchy of trees pointing to trees. So this is just the file content. And this is an important point to make, that because it's just the file content, and each of these Git objects can only have, a Git object is the hash of that object, and a Git repository can only have one object with the same hash in the whole thing. So that blob, imagine that's quite a big image, and it's stored in different directories with a different file name. Trees are still going to point to the same blob object, so you'll see that a bit more in a sec. And as I said, a tree can point to another tree, so this is like the equivalent to a subdirectory, which would then point to another blob with files in that subdirectory. So you can kind of picture, say, a more complicated example of, obviously your code base is way more complicated than this, but it's kind of, it's almost like navigating a directory structure, but because the pointers, if you think about linked lists, it's kind of like one thing points to another, points to another. Just touching on that point where before I said a blob has nothing to do with the file name, nothing to do with the path, it's just the raw content. So it's kind of, even though that's it looks like a directory structure, you can have like, if that's an image or whatever it is with the same file content, so the same SHA-1, the same hash, and that image is in this directory, then and then that image is also in this directory with a different file name, or the same file name, different file name, it doesn't matter, then it's going to point to the same blob, so it's not going to store that object twice or more than once. So it's very efficient. I mentioned about this git cat file, so the top one, -t, that says the type. So if you do git cat file -t, whatever SHA, it will say whether it's a commit, whether it's a tree, a blob, an annotated tag. If you do -p, think about p as like pretty output, and then the SHA, and then that does that kind of format you saw before. So for example, git cat file -p for a commit, you get that kind of thing which we saw before. If I take the tree, so 9d99, git cat file 9d99, then we're kind of like walking this hierarchical structure. So if we want to look at the main object, so that's a blob, e48b, git cat file e48b, then that shows the content. So you can see we can kind of look at the pointers and go to the next one. So I'm just going to, hopefully that gives a good idea. So I'm just going to give you, this is a bit blurry actually, just basically do exactly what we've just done then, but on the command line, so you can actually see it's actually on a real repository. Does all that make sense what I've said so far? Is there any, right, so I'm just going to get the terminal up. So this is, if I just do like a git log, I've got aliases here, but that's the same as git log. So I've obviously spent a lot of time prepping really good example commit messages here, and yeah. But if I just, so I've done a git log, we can see the shards on the left, which I'm sure you're all familiar with. If I just do what we did before, if I take one of these and do git cat file, why is that not auto-completing? Maybe it is. Oh yeah, I was wondering, because I knew I typed it before, but -p, well in fact no, let's do -t first. So that shows the type. So we know it's a commit we're dealing with. And if I change this to -p, then we saw what we did. So at the point of time in that commit, if I say, okay, I want to look into the tree, I want to browse the file system at that point in time, then I can do this. Okay, let's look into this subdirectory. So I can take this SHA, let's clear the screen and do the same again. So now in that subdirectory there's a file called main. So if I take this blob and do exactly the same, git cat file -p, the blob, then it shows the content. So it's obviously a very basic content. If I just,
You did main dot.
That should be alright. That took a long time. Wow, things went to be fast. So the subdirectory, if I look at main.cs, it's kind of, no, I don't want to install on the shop. Then that was the content. So you can see that It's not very exciting content, but you could see by doing that command, I'm just walking that thing. So does all that make sense to everyone? So whilst I'm here, how much time have I got? Whilst I'm here, if there's a few other little things on the show. So if I just, I need to close that actually. This is going really weird, it's quite slow at the moment. So in the Git folder, so we spoke about the objects before, so we've got these objects which I mentioned in that slide. We've got other stuff like, so I'm sure people have heard people say that a branch is really lightweight in Git, it's just a pointer. Have people heard that? So if I go to refs, heads, I've got a branch called main. If I go, this is a text file, it is literally just that, it's just a pointer. So as in, that's all it is. If I go to blah, it's just a pointer. Head is a term in Git which refers to the very latest commit you're working on, or it might not be a commit, the latest thing you're working on. If I load up that, that's a text file. So you can see that it's just a text file, and that's referring to this refs head main here. So if I just get another terminal here, I can make it a bit bigger. My laptop's going slow today, so if I make it a bit bigger. So you can see that I'm on the main branch here. Obviously I wouldn't recommend doing this, this is just an example. If I change this to blah, and then enter here, so this updates, you can see it's changed it. And there's some changes now because this is, I've just changed the data, I've not actually done a git checkout, so it's not changed my working directory, so it basically, if I do a stash, it's showing me the differences between those two branches. So you won't actually do this, but it's kind of just interesting to know that that's how it's stored. So if I go back to main again, and then enter, as you can see I'm back on main again, which is quite interesting. Tags again, I don't think I've got a tag actually, but a tag is like the same. You basically get a file with a pointer. The head, obviously that would mostly point to a branch, but you could change that to a char. It doesn't have to be a branch, it's just basically, it would then be a detached head. So it's not, so you're working unassociated with a branch. And that's kind of it. And we've probably not got time for questions, but yeah, hopefully that was useful and actually made sense.
What's the difference between a head and a tag?
Head and a tag. The head is just a general Git term for where you're currently working. So whatever branch you're on, the latest commit on there. Where a tag is kind of, it's just the tag in this concept is just a pointer to a commit.
But they're both just pointers actually on disk.
Yeah, but you only get one head because that's just the current one. Where with a tag you can tag any point in time, and you quite often use that for versioning if you have version number tags. Cool.